Welcome back to Applard builds an ISP out of his basement, or I guess it's like a spare bedroom, not really basement, but yeah. If you followed my previous video on the topic, you know that I am now the proud owner of an autonomous system number, 201726. And now that I have that number, and I have some IP space to go along with it, V6 of course, I can sort of play with what it's like to run an internet service provider just with cloud servers around the world. I can try Anycast, content distribution, stuff like that. So today I'm talking about how I automated setting up this infrastructure using Ansible, Netbox, and a couple of other things. And also I've built some new POPs since the last video too. That has made my traffic engineering even more complicated. So I'm not yet on to actually like hosting real services on this Anycast network, but I'm getting there. So if you want to see how my journey's going, then come along in this adventure. Also, I have a merch store, link down below for that. You're also welcome to support me down there as well with donations. I appreciate those on Ko-fi. I've also taken a number of donations from cloud hosting companies as part of this project, so I'll get into that later in the video. So when I last left you, I had a network like this. So I have node 1 in Warsaw, I have node 2 in Los Angeles. Both of those are hosted at Vultr. And I have node 3 at my home in Finland. So in the last video, I had used Zenith Cloud. They were the one that actually got the AS number for me. So they're just providing me with the IP range. So I was also hosting my POPs over here at Vultr. So I was paying them for this, for their cloud compute services. And basically just running some, what was I doing? Some of this stuff, cloud compute, relatively cheaply. So in that video, I had 3 nodes I was setting up. One was a virtual machine here in my closet. One was in Warsaw, one was in LAX. I was basically just opening Visual Studio Code remotely on each of them to edit my bird configs and using the terminal to reload bird and stuff like that. So I had 3 sets of similar but not identical config files. I was editing Etsy network interfaces manually. I was running IF up, IF down on stuff manually. And it worked well enough for me to do that test for that video. But it wasn't how I would want to really deploy anything. So if you've ever deployed more than one router in a network, you know that as soon as you have more than one router, you instantly have a routing problem. So for most people, that means going to something like OSPF for an interior gateway protocol. I am running both OSPF for the IGP as well as BGP to handle my internet-facing routes. So I've got a bit more of a complicated setup. And that very quickly meant that as soon as I was going to add a 4th node, it was basically too hard to manage by hand anymore, and I had to do some sort of automation. So enter Rackagenius. So these guys are a hosting company. They have Ryzen desktop as well as EPYC CPUs. They do VPS hosting, dedicated servers, and also game hosting. So game hosting is really latency sensitive. They're located out of, it says Muskegon, but they're in the Grand Rapids metro area. So Grand Rapids is not that far from where I used to live, and it's on a 2-3 hour drive. In Grand Rapids, there's a data center, there's an IXP. They're peering at that IXP, so they're not that far from that data center. At that data center, they have connections to 123net, who has connections to a lot of other upstreams in Detroit, and then they have a direct connection in Grand Rapids to Hurricane Electric. So that's where I have node 4 now set up. So I guess let's update the map to add that guy. So I used to have 3 nodes and 3 tunnels, so let's add another node. So put him here in Grand Rapids, and he gets a number, and he is number 4. So now we need some more tunnels too, right? So let's copy and paste some of these guys. So we're going to need 1 tunnel because we have a full mesh, right? So everyone has to talk to everyone. So that means he has to talk to all 3 of my existing nodes. So I got 3 more tunnels going online now. So that means now instead of having 3 tunnels, I now have 6 tunnels. And if I were to hypothetically add a 5th node, then I would have 10 tunnels. So obviously this is sort of how real life works as you keep adding routers in IXPs around the world, or even just routers on your network in general if you're a regional network. You end up with a bigger and bigger mesh of things that have to connect to each other. And so I could route through backbones. For example, I could add a POP on the east coast of the US and say all my traffic that goes across the Atlantic has to go through this POP. That's how a real network would probably be structured, but again, my network is essentially virtual, so it's not relying on real physical topology. But it gets harder and harder to manage. Now, it doesn't really get harder on the routers. I mean, they can handle millions of routes, no problem. It's just on me to manage it. So if I just had some automation that could create these tunnels, I'd be I'd be pretty happy, right? So that brought me to this video by Techno Tim. I'll have a link down in the description. And this is the video I watched to get my first Ansible playbook set up. So I found Ansible to be very overwhelming. Jeff Geerling has written whole books on it. It's a big topic. Jeff knows a lot about a lot of things too. But I wanted to just like run a couple commands on the server and figure out how to do that across 4 servers. And this video helped me figure out the basics enough to get a playbook written that would just update all the software and all the nodes. And I was happy with that as a first step. So now obviously I have a lot of playbooks now because I got this whole set of YAMLs and conf files and stuff. But that example playbook, I think, was this one. Well, I've expanded it a little bit since then. But essentially what it started with was it just said apt upgrade yes on all hosts. And I ran that and then I saw it and I was like pretty happy. So I go ahead and run this playbook. I'm going to run the pop setup playbook and use my inventory. Let's go ahead. We'll see what it does. So it's going to gather facts, blah, 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 blah. It's going to eventually run down all these servers and we should see it print out stuff that it did. And I guess we wait. I mean, it's not the fastest thing, but it's the server's time. It's not mine. I push updates to the config file, tell Ansible to run it. It makes sure everything is in sync and up to date, and I'm happy. Then eventually I added a few other things to this once I had the basic apt upgrade. So I wanted to add Proxmox backup server client. So I added that basically. So this is going to go through the process of adding the Proxmox repository, installing Proxmox backup client, creating a systemd service for blah, 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 blah. I did the same for bird. So we add a new repository for bird. Then we install bird from repository. And I got one for Taiga too. So Taiga does NAT64. I'm building this one from Git and installing it. So I think that's a pretty easy way to get started with Ansible. Just logging into hosts and getting them to run apt update, apt upgrade. It's a pretty simple script and it helps you work through a lot of the issues you have just getting everything to deploy. So one of those was how do I manage access? How do I manage SSH keys? I'm using SSH key-based auth for everything here, so no passwords. And I basically just created a new key just for this Ansible system, and I added it as an authorized key on all my systems. So now that I got Ansible at least figured out enough that I can write some really basic commands in Ansible, my next step was to automate those full mesh peerings. So in my config, I have 3 different places that I have to link all of these tunnels. So first I have to actually create the tunnels themselves. And I did that using Etsy Network Interfaces originally, using if up down. The Debian if up down, not the if up down 2, if up down ng, one of those others. That one supported sit tunnels, which I'm using, IP6, IP6. The second place is in the IGP, so that's OSPF. So normally OSPF uses multicast to automatically find neighbors. However, since I'm over a tunnel, multicast doesn't work, so I have to add the unicast addresses specifically. And the third place is BGP. So I'm doing a full mesh BGP. That means everyone talks to everyone else with a BGP session. And that means obviously I got to configure all those BGP sessions. So the first one I took a look at was the IGP OSPF. It was the easiest in Ansible, so that's where I started first. So as I've built up my bird config, I named them all bird something.conf. So the original bird.conf I just left in every system and added a new file called igp.conf that just configures the IGP. And then in the node, it then calls this include igp.conf to do the OSPF part. So I'd actually already done defs.conf, which I just copy and pasted between every system. I made a couple of changes here to template in the router ID in a couple places. But my next one was igp.conf. So I need to define a protocol. So I said protocol OSPF v3, OSPF 6. I'm advertising everything into OSPF that has the BGP to IGP community, which means that it's allowed to be advertised into the IGP, which is very few things really. And then I need to have these peers. So we use area 0, and for peer in peers, I create an interface. I use Jinja to come out with what the tunnel interface name should be, and figure out what the IP should be. Oh yeah, I probably didn't mention that you end up with a lot of config data here that Ansible uses to figure out how to configure things. And so I started at this point just writing it in host.yaml. So like here's host.yaml. It just lists every host. So they're in the group routers. I have Warsaw, router ID, gave it like a host name if it does NAT64, what pop it's from if it needs to do backups, and then what peers it has. So in this case, it lists these 3 peers. Those are the names of another key. So the Jinja template can say, if I have 3 peers, I can look up that key and find out what their host name is, router ID is, etc. And that's kind of what I did. So I said ton, and then the peers host name, replace dashes with underscores, and the peers router ID. So ran Ansible, it generated this igp.conf on all the systems, and then I could go into each of the systems separately and include igp.conf, and now my IGP was fully templated and ready to go. Then I came up with the next challenge. So I could have done the same for iBGP, and I largely did, but the next one I took on was network interfaces. And this is where I had to get some data. So enter Netbox. I actually made a video setting up Netbox, I don't know, 6-8 months ago, something like that. Probably link up here. I think it's already a little bit out of date because the instructions change all the time. But basically Netbox manages data. And the intent with Netbox is that you are editing this data manually. Netbox is validating it against a whole bunch of rules, relationships, things like that, to make sure the data is consistent with everything else in the database. And then from this database, all of your other automation can pull reliable data. So if we start pushing stuff into this, we have to be careful that we're pushing it well so we don't pollute the database with junk. So I was trying to use Netbox to include the information I needed so I could pull from it in Ansible. And that's where I set up my first Ansible role to set up networking. So Ansible has like a whole bunch of different types of data they can organize. And I thought about using circuits or virtual circuits or something for this, and I might still do that because that has advantages. But for now, I didn't actually do that. I just created virtual machines. So here in virtual machines, I had to create a cluster. I created a cluster for each cloud provider I have. So I have my cluster at home, I have Vultr, and I have Rack Genius and Grand Rapids. Then I made virtual machines. You'll notice the name matches the VM name of the host name, what host it's in, and most importantly, what its IP address is. So like if I click on this one, the one in Warsaw, you can see it has a primary IP, that's a v4 and a v6. And I added those to the interface, so I have on here interface LO and interface EMP1S0, what those IP addresses are. And I set this all up manually for each of these VMs based on how they got provisioned in Vultr, how they got provisioned in Rack Genius, etc. So now that I did the work to actually create these virtual machines in Netbox, that doesn't actually like create the virtual machine, it just creates a database entry saying this VM exists. And then I populated the important data that was important to me, so the network interfaces and their IP addresses. Now I can pull that data in Ansible and generate configs based on it. So I wrote this new file here called confnet.yaml. And so what it does is, so initially we build the peer list. We then go out to Netbox and we query for every virtual machine. And we just get a list of every virtual machine originally. And then we figure out what their IPv4 addresses are, if it's actually one of our peers. And we end up with a list of all of the peer IPv6 addresses. And so then based on that, we set up the tunnel interfaces and we set up the loopback interfaces. I didn't actually do like the primary real virtual Ethernet yet, because those all get configured a little bit differently by the cloud provider, mostly by CloudInit. So I just left those as they were, but everything else I'm doing with systemd networkd. So this one I wanted to loop, and you can't loop like a whole list, so I had to do an include file, and it loops over that file. So if I jump over to that file, it's going to configure a netdev and it's configure a network for each peer. So back here, this is basically saying every peer that I have to configure a new tunnel to. And I configure one tunnel using this file. And then over here, the netdev actually creates the tunnel interface, and the network creates the routes and the IP addresses over that interface. And those both come from these netdev and network template files. So then that points us here. So tunnel to peer, we give it a name, which we just take the name and replace dash with underscore. And then we need an IP, so we need my own IP, on my primary interface and my peer's IP. And these both came from Netbox via Ansible. So scrolling up a bit, they came from this query here. So Netbox NB lookup virtual machines, and then that returns a whole whack ton of data about the VMs. We filter it, and we end up getting the primary IP6 address and using that. So since my tunnels run under the real internet, they have to use the real internet cloud provider IPs, not my own ASN IPs. And so that means that I can't just programmatically generate what the IP should be because I know my prefix and I know my allocation scheme. I actually had to pull that data from Netbox. The network file is a little bit easier because we just say FE80 and then router ID /64. That's it. And then the loop back again, I add 420, which is my Anycast address. And I add a couple of other addresses that you can ping. So you could ping to AOF B240 1000::1, for example, if you want to. And at the very end, if anything changed, it'll run network control reload. Be happy. So a little bit about using AI for this. I did query 2 different AIs in this process, both ChatGPT, the free version, and Claude, also the free version. Now, I'm not going to pay for any AI services. I don't think they provide enough value to me for that. But if some venture capitalists want to light their money on fire to provide services for well below their operating costs or even free, I'm not going to not take their money, I guess. So I asked some of the AIs to come up with some of these snippets for me, and they were pretty good, but a little bit wrong every time, and it was absolutely maddening. But I think that whole process made me learn a lot more about Ansible. And so here are some examples of some places where the AI led me astray. So the first example I'm going to give is this Netbox lookup. So the lookup command, you do Netbox NB lookup, you tell it what you want to query, etc. There's a whole documentation on this. But the documentation didn't list all of these tokens here. And so I thought it was virtual underscore machines because, I don't know, the AI told me it had an underscore in it. And it turns out it has a dash instead of an underscore. And that led me on a chase for a long time because the AI couldn't figure out what was wrong. Also generating this map of all of the VMs by their IP address. The AI made something that kind of worked, but it was like a little bit off. It needed the dot value. It was just doing item.primary IP6 address. So again, it had good intentions, but I wasn't sure how the JSON was actually really structured. And I just kind of had to keep debug printing the whole JSON blob to see where it actually was. Because the code was generally correct, but some of these field names were just a little bit off. So with that out of the way, my next challenge in Netbox was setting up my exports. So as you might have seen, I have some local host entries that I set in every system. And now I want to configure how to add exports into the IGP and into BGP and what goes out to the internet. So previously I was setting these all up in the birdconf manually on all the systems. So I could choose which system advertised with prefixes, stuff like that. But I wanted to configure that in Netbox instead of in 4 different systems. So here's how I did that. So I come back over to Netbox, I went to IPAM and prefixes, and I now have some prefixes. So this is my prefix I get at home, and then this is my prefix that I now own. And within that I created more prefixes that are /48. That's the narrowest I can put on the internet. And I added these tags to them. So you can create tags, and so I could see what has the tag DFCAC, it's just this one. But basically, Ansible can search for this tag, BSP advertise DFZ. So that means advertise the DF free zone, and then AC means Anycast, and everything else means what pop it's in. So advertise Warsaw, advertise LAX, advertise Grand Rapids. And it can get a list of what prefixes need to get advertised there. And from that, it just uses the prefix and advertises it. Yeah, so here we query for the BGP advertise DFC prefixes, and then we do it again for advertise DFZ and then whatever pop we're in. So you end up with 2 lists, the Anycast prefixes and the local prefixes. Those come over here into exports.conf, where I then have, like, if pop is defined, that means we're exporting stuff. Then add any of the Anycast prefixes, add a route that black holes, and say it entered here and it's going to the DFZ. Same with the pop prefixes, it's going to DFC and it entered here. And then I also did the same for NAT64. So I create NAT64 routes. So this one's going to be 64FF9B1 router, and then 66FF9B::. And I have 2 instances of Taiga that run to do NAT64 here as well. So I guess the last question to answer now that I've got this whole pop set up, I got all the automation done, etc., is has this actually improved my Anycast situation, or did it actually make it worse? Let's look at some data. So this is everyone's favorite BGP tools. Here's my Anycast prefix. You can see now that I'm originating it. I have 2 upstreams, Constant, that's Vulture 20473, and RackGenius 32002. So Constant is advertising to Aurelion, Cogent, and GTT, who are then advertising on to most of the other tier 1s. They're also getting me directly to Comcast in the US, and they could also get me to AT&T, but that was causing me routing problems. And then RackGenius is directly paired with Hurricane and 123, and then 123 is peering on to Tata and Zayo, and Hurricane is going on to Deutsche Telekom and Lumen, it looks like. So, looks pretty good. So by adding the second POP with a different company other than Vulture, I have different upstreams. So if I added more Vulture POPs, I would probably have more connections to Aurelion, which would be good if your local ISP is paired with Aurelion, but they're not the cheapest to pair with. I've heard that they're extremely reliable, but again, not every ISP pairs with every other ISP directly. So if your local ISP is paired with Hurricane or NTT or someone like that, you would have had a worse time if I added more Aurelion POPs instead of spreading out across the different tier 1s. But until I have a decent distribution across continents, I'm still going to have some customers in Europe that are going to my new Grand Rapids POP. And here's what I mean. So Ripe Atlas here. Can I make you bigger? Can I make you full screen or something? So anyway, I got some pretty good coverage here. So Canada, and not the worst. Looks like they're going to LAX. These guys are probably all doing okay. This one's going to Grand Rapids. What path are they taking? Looks like they're going across Hurricane. Interesting choice. This guy, no idea where he's going. I wish that these trace routes would work better, but so many IPs block ICMP. So this is Grand Rapids. That's close. Oh, that's an anchor. I think it's in Detroit. That's FJ. Not sure, but I'm guessing this anchor is in Detroit. So they're probably connecting to 123 directly, who then takes it over to Grand Rapids, which is over here. So most of the US, though, is not doing too bad. They're either hitting up Grand Rapids or LAX. And some of them go to the wrong side of the US, but that's not the end of the world. What is not fantastic is these guys over here. So you can pretty much tell who's going to Poland and who's not based on who's green. So that's 1299, that's Aurelion. Again, 1299, Aurelion. But what about someone here that's dark? So who are you going through? I have no idea who they're going through. Why do you guys always block ICMPs? So it's like this guy's going to Hurricane. I don't know where they're going. So if you end up peering with Aurelion, you're in a good place. If you peer with Hurricane, you're probably not. So yeah, oh, Init 7. Init 7 is not doing great. They're probably paired with Hurricane in the US as well. So basically, if you're preferring peerings with Hurricane because they're cheaper or something, you end up at my server over here because it has good peerings with Hurricane. So I need to find someone in Europe that has better peerings with some of these tier 1s that I don't have good peerings with already. Because adding more periods with Aurelion won't help, unless I want to be exclusive to Aurelion, basically. And similar view here in Kuifu. Some people are just taking really weird paths. So I guess the lesson is, as I add more POPs, the situation gets worse, which means that I totally understand now why major content distribution networks have a lot of POPs around the world. So like, why would you need both Chicago and Virginia, for example? And it's because your customers are still probably going to go to the wrong one, even if you steer them. But at least if there's 2 in the general area with different peerings, you might have a better hope of them going to something relatively close. So then I guess that just leaves, where am I going to go from here with my mock ISP setup? So I got into this because I had a couple different things I wanted to play with, and all of them would have benefited from a lot of address space. And only one of those was Anycast. So one of those is I want to do Anycast. So I want to migrate some of my workloads that I have now in Ashburn, Virginia, onto this Anycast network. So that's my own personal website, things like that. I've been thinking about hosting DNS as well, maybe for a subdomain, or maybe I'll get a different domain just for this, because I really don't want to mess up email, especially on my main domain. But so if I do my own DNS hosting, I could geo-distribute that. Then I could play with how to get geo-IP-based DNS instead of just Anycast and compare and contrast those options. So that's a path I want to go down as well. So that'd be setting up Nginx or Caddy or something on all of my POPs to serve local and cached content. My website's static, so it caches like super well. But that's just one path I want to go down. The other path I want to go down is more of a physical ISP side. So I made a video before on GPON, passive optical networks. I want to kind of dive into the more access layer. So this stuff I've been playing with BGP peering, that's like the core network side of an ISP. Every ISP has to get transit from someone. If they're decently big, they're probably doing quite a bit of peerings. They might be in some IXPs, etc. So I'd like to play with that if I can. I kind of had some offers to set up a VPS in a Dutch IXP, which would be super cool if I can do that in Amsterdam. Then I could tell you what that whole process is like, I guess. But I also want to play with the access network side. So GPON, how do we provision customers in GPON, give them their DHCP prefix delegations, looking at things like 464XLAT, MAP-T, DS Lite, those kinds of technologies that are all made use of having this wide IPv6 address space, but not necessarily all that cloud presence. So I would have been fine with just one POP if I just wanted to advertise my /40, just to have a /40 that works that I can allocate out of. In addition to GPON, I am kind of into wireless ISPs like WISPs. I know that they're not like technically a great solution. In most of the world now, you just get 5G and you're happy with that, or 4G, or you run fiber. But I really like this whole mesh point-to-point stuff. Someone commented on, I think on, probably on my last video, but I've been hearing a little bit recently about czfree.net. Maybe I'll put a link to I think a Czech translated Wikipedia page that describes how that worked. Basically, around the early 2000s, a number of people were setting up their own sort of internet in Prague based on like 802.11b point-to-point radios or Ranja 10 megabit optical radios. If you have any of those Ranja radios, I would love to take a look at one. I love optical networking. Super cool to me. But I got some other projects going on that side, setting up more mesh networks. If you're in the Seinäjoki area specifically, I would really love to try to mesh with you in any way possible to transit IP traffic. I think that'd be a super cool setup. But how those route, how you do maybe MPLS across your access network, things like that. Because I know those are interesting networking problems that I'd like to play with as well. So that's where I'm going to continue down those roads on this project. It's not all about Anycast. It's also about the ISP side of it, the customer access side, that sort of thing. Doing that with my address space. Here I got the mono gateway. I'm sure if you follow my channel, you also follow Tomasz. He's been designing and building, or him and his partner Aljaž have been designing and building this router from the ground up for over a year now and posting about it on YouTube. So I was pre-order number 59. I got my hands on mine finally a couple days ago. I did a live stream testing it. So currently it's flashed with a super development build of OpenSense that Tomasz compiled for me like 20 minutes before I installed it. I would long-term like to get this running on something more mainstream-based Linux. So I really like Systemd, and I'm not a huge fan of OpenWRT's web UI because I find it relatively confusing. So I'll probably end up doing some sort of build with Mono's kernel with hardware offload, which is basic Debian on top of that, and then I'll automate everything else in Ansible or in Bird for dynamic routing or stuff like that. I've thought about switching to FRR. I started with Bird because it was way less resource intensive. I really like the filter language. I found it to be very easy to use. Although FRR has a lot more features and certain functionalities, so maybe I'll have to switch to that later, but we'll see about that. This is going to get installed at my house here once I'm happy with it, and it will act as the new Seinäjoki node, routing both my home ISP and my simulated, I guess, AS number ISP. All that traffic will end up going through this guy here. So that's the long-term plan for this. I am Applard. You're more than welcome to buy my shirts. Comment down below if you have any experience with any of these things, any tips you can give me. I might do some more live streams. I've been thinking of doing some live streams of like doing network labs live, where I start with an idea or a drawing of what I want to happen, design out all the virtual machines that are going to make up this lab or real hardware or whatever, connect them all up, configure them, get them running. So I've done that with BGP already. I did that with this guy. I'm thinking about doing segment routing, either SRv6 or MPLS. So if you're interested in that, I guess tell me what times you're free. If you want to help with my AS project, that'd be super cool. If you have any old equipment, especially Ranja, I love looking at that stuff too, even though those videos don't tend to do as well. They're interesting to me at least. And I feel like doing this sort of content like this video performs better now on YouTube because it's authentic. So like if I make tutorial videos, they used to do really well. But now I feel like everyone's just going to AI and asking it to hack them something together that may or may not work, and not searching for videos on YouTube anymore. But this sort of authentic content of what I've actually done in my lab, that kind of thing, I think will still perform well, at least I hope. So let me know if you like this kind of content, if you want to see me do more about ISP access networks, ISP core networks, Anycast, DNS-based geodistribution, stuff like that. Let me know in the comments, join my Discord, etc. So I guess I'll see you guys on the next adventure.